Hey everyone, and welcome back to another Explainer. Every single second of our lives we are interacting with this massive, invisible shield, but we rarely ever give it a second thought. Well, today, we are going to change that. We're exploring the incredible, multi-layered architecture of Earth's atmosphere, taking a journey all the way from the ground beneath our feet to the very edge of outer space.
Seriously, look out your window right now. It probably looks like there's just a whole lot of empty space between you and the clouds, right? But there's actually a massive blanket of gases stretching nearly 700 kilometers out from the surface. This is our atmosphere. And without this invisible force, life on Earth simply would not exist.
We tend to think of air as being completely weightless, but the atmosphere is essentially this giant ocean of gas, and that gas actually has mass. The sheer weight of this stack pushing down on us creates what we call atmospheric pressure, which meteorologists measure in millibars to forecast our constantly shifting weather.
Now, to really map out this invisible ocean, we have to track our altitude, which is just the height measured straight up from sea level. As your altitude increases, atmospheric pressure and temperature change drastically. And it's these extreme changes that carve our atmosphere up into distinct, highly specialized layers.
Okay, but what's actually in this air we're breathing? Well, a massive 78% of the lowest layer is nitrogen, which is a superabundant but low reactivity gas. The really crucial 21% is oxygen. That's the VIP gas required for both breathing and combustion. And that remaining 1%? That's just a trace mix of argon, carbon dioxide, and water vapor.
All right, here is our flight path to space for today. We've got 5 main stops. 1, the troposphere. 2, the stratosphere. 3, the mesosphere. 4, the thermosphere. And 5, the exosphere.
Section 1. Launch. The lower layers. Welcome to the troposphere. This is the layer directly hugging the Earth, literally where you are right now. Incredibly, nearly 75% of all the air in the atmosphere is packed into this one single layer. And because of the Earth's shape and temperature dynamics, it stretches about 15 kilometers high near the equator, but shrinks down to just 8 kilometers near the poles.
Because it's so incredibly dense, the troposphere holds almost all of the atmosphere's water vapor and dust. And that means this is where our weather lives. Every storm, every snowfall, and every gust of wind you've ever felt happens right here. It's also our main aviation highway for helicopters and commercial airplanes.
Moving higher, between 15 and 50 kilometers, we cross into the stratosphere. If you ever see a towering cumulonimbus cloud with a perfectly flattened top that actually illustrates this boundary, that distinct anvil shape forms when a massive weather cloud hits the stable boundary of the stratosphere, where strong winds blowing in one direction shear the top completely flat.
The air up here is incredibly dry and stable, which makes it perfect for jet cruising. But the stratosphere's absolute most vital feature is the ozone layer. This acts as Earth's planetary sunscreen, actively absorbing dangerous ultraviolet radiation from the sun. And because it absorbs so much solar energy, the temperature in the stratosphere actually gets warmer the higher you go.
Section 2. Deep space, the upper layers.
Spanning 50 to 80 kilometers up is the mesosphere, and this is the absolute coldest layer of all 5. Since there's very little ozone up here to absorb solar heat, temperatures at the top can plunge to minus 90 degrees Celsius. It is so freezing cold that trace water vapor actually turns into high-altitude ice clouds, which can sometimes catch the sun's rays after sunset and glow in the night sky.
Now, crossing the 80-kilometer mark, the whole environment undergoes a radical flip. We move straight from the coldest extremes directly into the thermosphere. Here, sparse air particles directly absorb intense solar radiation, so the temperature spikes dramatically, getting hotter and hotter the further up you go.
But extreme heat isn't its only defining trait. Extending up to 120 kilometers, the thermosphere hosts the Earth's most spectacular light shows, the auroras, like the northern and southern lights. It's also the orbital home of the International Space Station, which zips right through this hot, glowing layer every single day.
Finally, starting at about 120 kilometers, we reach the exosphere. There is no hard wall or sudden drop-off here. The gases simply become thinner and thinner, gradually fading away into the vast, endless vacuum of space. This right here is the absolute edge of our protective shield.
Section 3. Touchdown and recap. Our protective shield. To summarize, our atmosphere really is like a superhero. It's a perfectly balanced survival system.
It provides the exact 21% oxygen mix we need to breathe, supplies the carbon dioxide necessary for plants to grow, and utilizes that stratospheric ozone to block lethal UV rays. It even acts as a physical barrier, incinerating meteors long before they can ever reach the surface.
So that wraps up today's explainer. We've seen how this incredible 700-kilometer invisible ocean provides literally everything from the air we breathe to the climate we live in. But I want to leave you with this. If you could build a spaceship right now to visit any of these extreme layers, which one would you choose and why? And on a more serious note, as we continue to emit greenhouse gases and alter this delicate chemistry, how far can we push this invisible shield before it stops protecting us? Keep asking those big questions, keep exploring the science, and I'll see you in the next explainer.